Guys, second video for 1.4 here. I'm going to use these pain levels, which will kind of indicate how we go. So it does get a little bit tricky, as you can imagine. But I'll put a face next to most of these things here. So first thing right here, this should be pretty easy. Like if you went into the hospital, like you really probably shouldn't be in the hospital if you're feeling this good, right? But basically, if I gave you this problem and I just said to, add your like terms here, that's all that you would do, right? So you'd have 3x, so I don't know, however you guys did this in middle school is going to be fine. If you think about adding the opposite, you make everything inside the opposite, you can do it that way. But basically you're going to get an answer of 5x minus 4. Man, what does this have to do with anything we've done this, lesson with the i's and stuff? Well, basically, as you can kind of guess, this is exactly how you treat it if it was, 3i plus 7 minus, 11 minus 2i. You simply just add like terms, right? So this is still pretty easy. All you're going to do here is add like terms, right? So this is a plus sign, makes it a little easier. Your final answer, you can do it and then, resume the video, or you might just be able to get it in your head right now. It's going to be 13 plus 3i. And that's it. Now, if you said 3i plus 13, is that correct? Mathematically, yes, but I would actually take off a half a point. You always want to put thing into standard complex number form. And what the heck do I mean by standard complex number form? It means a plus bi form, right? So make sure that the I goes at the end. Again, unless there's like a square root and then you put it in front of it, but for the most part, the imaginary number part should be at the end, and then the real number part should be at the beginning. Okay? Again, a little bit more difficult, so you can see this guy's face. The only reason is because there's a subtraction sign. So go ahead and do this one and then resume the video when you're done. All right, if you did this one, the answer is just 4. And that is actually technically complex standard number form, standard complex number form. You could write it as 4 plus 0i, but you certainly don't need to, right? 0 times anything is 0. So you don't need to write that, but I'm just showing you that, technically it is complex number form when you write it that way. You could just say 4 though. I have a video on here. I'm going to post it on Schoology. You can watch it. I'm not going to play the video within the video. I think that might just blow people's heads off. But, you may be able to start this and be okay with this without watching the video. But if you do want to watch the video, pause this video, go on to Schoology and watch. I don't know what I'll title it, but you'll see it. It's just working with complex numbers with multiplication and division versus addition and subtraction, which is what we just did there, right? So if you want to just get started, you can kind of do this. I'm just going to post the answers, though. I'm not going to, go through all of the steps, but essentially, it's I root 7. You distribute the I root 7 to both terms, and you just kind of go. The trick is you got to get an I squared, which is going to turn into a -1, and then that's kind of where the videos will really kind of explain it a little bit better. But if you kind of know what you're doing, you can start these, and then just see if you get the same final answers. So this first one is going to be -8 root 7 plus 4i root 7, right? That's standard complex number form. The real part is first, the imaginary part is second. This one over here to the right, I'll just show this one out really, really quick. Again, if you're thinking, what's the matter with this? Well, the problem with this is that I is technically a square root, and you cannot have a square root in the denominator, right? That's why you can't just leave it as this. This is a square root in the denominator, even though you don't see the actual radical. Right, so the 2 is fine. The I is the problem. I'm just going to multiply it by I over I. And then, you distribute this I to both. 2i times I is going to be -2 because I times I is -1. Right, and your final answer is going to be, I believe, 5 halves minus 7 halves times I, right? And when you write this, make sure you can put the I in the numerator. I'm not such a stickler for that. You can put it up here with it. If you write off to the side, just make sure it's not next to the I, next to the 2, because it's not. It's actually in the numerator, or you can just keep it separate, but just don't write it too low. If you got 5 minus 7i all over 2, that's okay. But again, with a plus bi form, we want to break up the a and the b and write it as two separate things. This one down here, you're just going to have to, multiply, distribute the I root 5 to both, and then distribute the negative 2 I root 3 to both. Kind of a funky answer, but you're going to get a long-winded. You're going to put all the real stuff first. So negative 8 root 5 plus 16 root 3. And then the imaginary stuff plus 15i I minus 6i root 5, I believe. And again, there certainly could be a mistake, but I think those are okay. And then here, it's just like your conjugate problems from before. You have to multiply by the conjugate to get rid of the square root in the bottom. Final answer over here, we should be getting 1/4 minus 7/4, and then times I. Okay? And again, you can check with the people next to you if you didn't get those answers. Maybe they did and they can help you out.